here are some compounds or some molecular formulas. So we want to name the compound, draw the Lewis structure, determine the electron geometry and the molecular shape, estimate the bond angles, determine if it's polar or nonpolar, and determine the type of intermolecular forces of attraction. It's a lot of things that you know how to do now. So we've actually done, I can only give you so many examples before you start to repeat because we've seen basically all of the possible shapes. So um, let's just start with the top though, CCl4. Our first task is to name the covalent compound. So here we remember we use Greek prefixes, and so this would be what? Carbon tetrachloride. Next is to draw the Lewis structure. Next is electron geometry and molecular geometry, and in this case, they're both tetrahedral. So that twice, and then estimate the bond angles between carbon and chloride. Three of them would be 109.5. Determine if it's polar or nonpolar. So this is nonpolar. So that means that the forces are dispersion. All right, next. I'm going through this quickly because I am going to assume that you take the time to pause it and answer for yourself and do the hard work for yourself. And here we'll just check. All right, CO2 is carbon dioxide. You've drawn this Lewis structure many times now. And it's a linear electron geometry and linear molecular geometry. The bond angle is 180 degrees. It is a nonpolar molecule, even though it's a polar bond, and therefore we have dispersion forces of attraction. Next, NH3, which has a special name of ammonia, but we can still give it the technical name. The standard nomenclature would be nitrogen trihydride. Okay, and the Lewis structure. Again, we've drawn this one many times. Looks like so. The electron geometry is tetrahedral, but the molecular shape is not tetrahedral because of the lone pair. It's trigonal pyramidal. The bond angles would be approximately 109. This is a polar molecule, and it has hydrogen bonding intermolecular forces. Okay, then the last one is CH2O. And we've only talked about naming binary covalent compounds. That means it has two atoms. And so we're not going to have a standard name for this one. So that's kind of an exception. It is called formaldehyde, which you may or may not know. It's okay if you don't. But we can still draw the Lewis structure. Again, we've done this one. And the electron geometry and the shape are both trigonal planar. The bond angle would be 120 degrees. It is in fact polar, and it has dipole-dipole intermolecular forces. Okay, So that actually wraps up chapter 4 for us. And so I encourage you to take a look at the back of the chapter. And on page 144 is a list of all of the core concepts of the whole chapter, separated by sections. Followed by that is a list of keywords in alphabetical order. And followed on page 146 are additional exercises.